These metal-moving hammer-like structures work to extract oil from underground, often in the middle of nowhere. All of this probably leaves you wondering, how do they actually work and what happens to the oil once it's taken from below ground? Called pump jacks, oil horses, oil derricks, these large metal structures are crucial to supplying the US and ultimately the world with its oil needs. They function as traditional sucker rod pumps, known more technically as reciprocating piston pumps, and are made up of 5 main parts: the prime mover, the crank, the Samson posts, the walking beam, and the sucker rod. The Samson posts are those that make up the main A-frame of the structure. They function as the basic support, allowing the pumping mechanisms to work together. Atop the Samson post sits the walking beam, attached to a piece called the horse head. These parts together make up the major lever arm in the structure, responsible for most of the pumping. These move up and down due to the rotational movement from a smaller arm called the crank. The crank usually has a counterweight to balance out the forces on the oil derrick, and it gets its power from the prime mover, usually through a gearbox. The prime mover is simply a complicated name for motor or engine. This supplies the rotational energy to the system that works through all of the subsequent parts to create the bobbing pumping motion that these derricks are known for. But all of that was a complicated preface to how these massive pumps actually work to remove oil from underground. Attached to the horse head is something called a sucker rod, which moves up and down in the well hole. There are 2 stages of the pumping process, the upstroke and the downstroke. Simple enough. On the upstroke, the derrick pulls the rod up from the bottom of the well to the top of its range of movement. There's a valve attached to the bottom of the sucker rod, known as the riding valve, and another at the bottom of the well, known as the standing valve. On the upstroke, the riding valve is closed and the standing valve is opened, allowing oil from the source to be drawn up into the well. Then, on the downstroke, the riding valve opens and the standing valve closes, putting the oil from that stroke on the other side of the riding valve. Repeating this process over and over again slowly pushes the oil up and out of the well at a rate determined by the pump's speed, size of stroke, and well diameter. This functionality works similarly to how most pumps work using what would traditionally be called a check valve. This valve functions identically to how the valves in the oil derrick work, allowing flow of a fluid in one direction but not the other. As the oil horse operates, the oil is forced out of the reservoir and the valves don't allow it to flow in the other direction. Their size is usually directly correlated to how deep an oil well might be. The larger the oil horse, the deeper the oil reserve. This relation is simply because bringing oil up from deeper depths requires a significantly larger amount of effort. These derricks generally pump anywhere from 1.5 to 10 gallons of oil per stroke. The liquid extracted is usually a mixture of crude oil and water that then needs to be separated and refined. As for what happens to the oil once it is pumped, there are 2 main options. Depending upon location, some derricks will fill a large container with the oil that is then trucked away at certain intervals, or the oil is directly pumped to a central holding station through a pipeline. While renewable energies may be making a strong play for powering the world, oil will likely be here to stay for quite some time. All this means that oil horses across the country will keep on bobbing, bringing up oil from deep beneath the surface. And now, when you drive past them on the road, you can understand that these seemingly complex machines are actually just large, simple pumps working to help your car keep on moving. Thanks for watching. If you want to check out more of our videos, you can click here, here, and here, or you can browse our channel, and as always, be sure to like, share, and subscribe.